doing some recording so that they can begin to see this stuff. We'll put it up on YouTube so that they can get caught up. So the thing that's going to change today is that width is we are going to pretend that that width gets really, really tiny. So tiny that it's touching. And so I'm going to call this back. Do this to me. Well, it's this guy's up there. I think we've got him back. So I've let that width get back until he's really, really tiny. So just like we did when we were taking the limits with derivatives, that change in x is going to change into 18x.
So we don't have to write triangle.
So we don't have to write triangle. Because remember, triangle is change. And what's happening up here is triangle. Oh, there's triangle. There's the big triangle. This is the little triangle. Notice the little triangle looks so much like a D that we just call it a D. So there's a little triangle. Looking at this, folks, is this an inscribed or circumscribed?
Inscribed.
So this would be the lower limit. But if they were all really, really tiny, would there be a lot of difference? Can you see it'd be so tiny that I wouldn't have any difference at all? So I wouldn't have to do that LRAM and RRAM and add them together to find the average. And then up here, we were doing the height, which we're going to put in with a function of x. Really, we kind of did that because we put in the numbers, and that told me how tall that was. So, for example, if this is 0, what's this mark? So what would this mark be? So I'm going to think of him as a half. How tall would I be going when he hit up there? That's not a half. I kind of do it wrong. So x equals a half. Y equals x squared. So why is it a quarter? Yeah. You just plug it in. And so when you plug that in, that finds the height. That's what f of x is. So the thing that's going to be brand new today is when we take derivatives of things, what is the derivative of that? What we want to do is we want to invent today something that's the opposite of derivatives. He's the anti-derivative. He's the inverse derivative. And guess what? This guy right here is going to undo a derivative. So the way you undo a derivative is you take the integral. If I use the word antiderivative, integral, they all mean the same thing. So let's turn this around backwards, because the thing that we're going to learn to do is we're going to learn to think backwards. I'm going to isolate that. And now I want to invent this new thing called an integral that makes it go away. When you integrate, it makes the derivative disappear. Now you're kind of used to those. You're taking inverse signs. You've got to make the signs go away. In a lot of ways, that's what a half did for a fraction in division. Now, the opposite of multiplying by 2 is dividing by 2. Same sort of thing you do with addition and subtraction. Add 2, opposite of that is subtraction.
Can't you just put it back next to?
Yeah, it almost comes right back. So let's see what happens. So when you do that, that makes that derivative disappear.
And it's back to x squared.
And you guys know that that x squared kind of comes back up there. Now, there's a little bit, see how the 2 jump back up in there? Now, there's a little bit of a problem. What would have happened if in that original one, I changed the problem so instead of plus 3, you would like a plus 3. 3 is a constant. What happens when you take the derivative of constants? You don't know that. So to be on the safe side, you're going to learn pretty quickly that every time we take that integral, we also want to add a constant. That's a C. So we're going to make the letter C stand for constant.
So we would put the 3 down here and put the 3 there.
Well, we don't know what it is sometimes. Now, later on in the next section, they're going to give me enough information so I can actually find out what the constant
Will
was.
it start with the 3?
So this time we're going to learn to go backwards. But it's kind of helpful that we start to see patterns. Let me give you one that we haven't seen. Let's imagine that I asked you to integrate x to the third. Now, if you're thinking backwards, can you recognize that that next exponent is going to be higher and he's going to be x to the fourth power? Let me give you the answer. And then let's say if you can see it backwards. So it's going to be x to the fourth divided by 4 with a constant.
Why 3x? Wait, is that already taken the derivative?
So I went ahead and took the integral for it. So this time they've already taken the derivative.
And that's what the
And now we want to see if we can learn to drive this beastie backwards. So today we start driving calculus backwards. Uh-oh, yes, I know. That rear view mirror.
I couldn't even go forward.
Well, let's check going forwards. So if you're going to go forwards on this guy, if you took the derivative of this, what would happen to the 4? It'd go out to the front and you'd be dividing by 4. Okay, so I've got 1 fist to 5 line. Let's see where other people are fist to 5 line. Talk it over. Why don't you join a group, Kayla? Your group is deserted here. It helps to sort of talk this out with each other.
Why did you divide by 4?
Well, because when that 4 came out in the front, I want that 4 to go away.
But then why did on the top why did it go back?
Because I sort of made it easier. I already threw a 2 in there. I was thinking ahead.
So x to the 4th over 4, the derivative is x.
So, yes. Now, let's check it. So if I asked you to take the derivative of x to the 4th over 4, you realize that's like a 4th. What happens to the 4 when you take the derivative? So the 4 would come out in the front, The power would drop by 1 and we get 4x to the third. Does that bring back memories from way back in December? All the way to last year. Wow.
So it's 4 plus 4 is.
And what is 4 divided by 4? Which you will notice is right here. So why did I ignore the c? What's the derivative of a constant? 0. So the constants are going to drop out when you take the derivatives. Because sometimes I need to have to solve the problem.
Okay, they're gonna get harder.
Wise woman.
Harder.
So you send her down to do that parade in Denver, and they just come back so smart. How'd I go, by the way?
It was really cool.
I kept looking for pictures of you, but I couldn't find you.
It's on channel 4, but that was good.
Okay. Okay, so let's try another one. If I asked you to integrate x to the 5th,
It's probably end up x to the 6th.
x to the 6th, wow, that's pretty impressive.
Yeah, we're on 6.
And it's, oh wow, you guys are like
Nice.
fantastic.
Plus C maybe.
And plus C.
But you don't have to.
Yep, you got to write the plus C. You guys really saw it, man. You guys are pretty quick. So let's try and write this in a pattern so that we don't have to second guess it each time. So we generally like to have the letter N stand for the power. And so the way we would say that is the next number is 1 higher, so we say N plus 1.
What if it's a negative?
Well, it'll all work. The only thing that'll happen is if this number was 1 over, if that was an x to the minus 1, we'd be messed up. But we're going to cross that bridge another day.
Okay. So no negatives yet? Well, what happens when you do need the C for the problem?
Like you need to have the C every time for this.
Yeah, but what happens when you need it to solve it?
To solve it, they'll give me more
We'll cross
information.
that out.
They'll do things like they'll say at the initial starting point, the height was 20 feet above ground and the initial starting velocity was 100. And then we'll turn around and we'll find problems like that. Readings. Okay. Keep one in band, people.